So in this question, we're being asked to prove that the given triangle is an isosceles triangle, but not an equilateral triangle. So there's actually two different methods we could do here. One would be to use the distance formula to compare the length of all three sides, show that two of them are the same length and the third one's different. Another way is to use the Pythagorean theorem here to help us out, and that's the method I'm going to do. And let's start by looking at the length from B to C. So what we can do is create a right-angled triangle outside of the actual triangle here, where the hypotenuse is the distance that we're looking for. Now that's pretty helpful because we're dealing with just two horizontal and vertical lines here, both with a distance of 4. So real quick, if we do the Pythagorean theorem here, we would see that the distance from B to C is the square root of 32. We could also simplify that. I know that's the same thing as the square root of 16 times 2, which becomes 4 root 2. All right, now let's take a look at the line from A to C. So here we've got a horizontal distance of 1 and a vertical distance of 2, 4, 5. So we'll use the Pythagorean theorem here again to find that hypotenuse length. That would be the square root of 1 squared plus 5 squared, which is root 26. And finally, the line from A to B, if we did the same thing, we would have a horizontal distance of 5, vertical distance of 1. So because we have the same numbers as before, we will get the same distance of root 26. So with that done, we can now conclude that this is an isosceles triangle because the lines AC and AB are the same length. They're both root 26. And the line BC is different. It's 4 root 2. So I'll let you read the detailed explanation I've written out there to conclude this answer. And yeah, that would be it for this video. Thanks for visiting JD's Preparation.